So an ANOVA is actually an analysis of variance. It's an analysis of the variance between the groups. Remember, we said full-time, part-time, casual, and the variance within those groups. Okay, so I'll explain that a little more. You can have a one-way ANOVA or a two-way ANOVA. The one-way ANOVA is when you have only one independent variable. So in our case, the independent variable is the willingness to whatever it was. I'm just going to call it willingness. And then let's say, and then the independent was the level of employment, right, which had 3 groups. But let's say you wanted to find out the level of willingness and the level of, let's say, knowledge between those 3 groups. You'd still have to run an ANOVA, but you'd run a two-way ANOVA because you have more than one independent. Sorry, it doesn't really matter. The point is you're running one-way ANOVAs. We don't do two ways in this class. I don't want to over-explain that because I feel like I'm not 100% confident on it. It doesn't actually matter. So for now, for the exam, it will, and I'll make sure to go over it for that. So you make the same assumptions as the t-test. Remember, we talked about it has to have one categorical independent variable, and then has to have a continuous dependent variable, has to be homogeneous in variance. So it's all those same things. Plus, you want to compare the variances between those groups to the variances in each groups. So you have more than 2 groups in your independent variable, in which case we do, okay? You can't do, like I said before, you can do a bunch of t-tests, but it lowers the significance. If you have a study and it comes out and you have 3 groups in your independent variable and you've done 3 or 4 t-tests, your study will be rejected right away. So how do we do this? So what we need to do is we need to figure out, let me draw those circles again because I feel like that might help us. We have 3 groups, right? We have your part-time, your full-time, your part-time, and your casual, okay? And within these groups, within the full-time, there are scores, right? It's for the test of willingness. So you've got like all these scores. Just pretend that I'm doing this better than I am, okay? You've got a bunch of scores here, and you've got a bunch here, okay? Like so, it doesn't really matter, okay? So what you're measuring when you do an ANOVA is you're measuring, so you take the full-time group, for example, or the first group, whatever you're measuring, and you determine the mean of the scores for the full-time group. So you get your mean, okay? Whatever it is. You get your mean for this group, you get your mean for this group. So now you know what the average score was for full-timers, for part-timers, and for casual employees. Okay? And so you want to know how much do these scores inside of this group of full-timers, how much do they vary? What's the variance inside? What's the variance inside this? What's the variance inside that? Okay, and then you want to compare that to the variance outside. And I mean, there's no scores outside, right? All the scores are inside, but you use means to do that. So you take the mean of this, the full-time, the mean of part-time, the mean of casual, and you compare it to the difference in the means or between the groups. So it's going to be a lot of like in the groups and between the groups, because that's really the basis of the ANOVA, right? So you want to know, so you can see that there's different test scores, whatever. Is the difference in these scores related to the independent variable, or in other words, something outside of the groups? Sorry, sorry, let me start again. If the variance between the means, okay, is greater than the variance inside the means, okay, then that means that the difference in those groups has to be due to the group that you're in. Do you know what I mean? The difference is because you're in this group, or you're in this group, or you're in this group, because the difference between them is so much bigger, right? The closer together these are, the more blurry that line gets, kind of. So if the variance between the means is greater than the variance inside the groups, then you are going to assume that it is the independent variable, or the groups themselves, that is causing that variance. Don't worry about if you don't like fully understand that. We'll go over it again, and I don't know that you necessarily need to really understand. Well, it's good too, but anyway. So in an ANOVA, I'm just looking through the notes. We're interested in knowing if the variance that's happening between group 1 and 2, between group 1 and 3, and between group 1 and 4, no, it shouldn't be 4, sorry. It should be 1 and 2, 1 and 3, 2 and 3, etc., is greater than the variance that's happening inside the groups. If so, then we can say it's a group effect. So if the null is true, the variance between will be less than the variance inside. So again, this is like stuff when you're doing the question, you're going to have to come back and look at these again, just to double check. If the variance between two of the groups is bigger than the variance inside the groups, that means it matters. It matters which group you're in. It's the group that's making the difference. So that means you have a significant finding. ANOVA, the thing to remember about ANOVA is that it gives you a ratio of the variance between and the variance within. This is like test question material. You know, what is it? What is it giving you? The larger the variance between, the larger the F-stat. And the F-stat is basically just like your T-stat that we talked about earlier, where you have like a critical T and then you have your T-stat, except the F-stat is what we use when we're talking about ANOVAs. It's the level of statistical significance of the test. And so again, the greater the variance between, the higher that F-stat is going to be. And that means the level of statistical significance is going to be higher as well. So the only thing that you need to keep in mind is that an ANOVA test is only concerned with the total variability, okay? So whatever variation it's going to give you the total variation between this group and this group. You don't know the differences between these groups, which I know is confusing because we drew those arrows earlier. The point is, you could have, the difference could be more like this. The point is that this difference is what matters, right? And it's what we're measuring. So there's always going to be a variation of scores within the groups, just by chance. So we want to measure the differences that are caused by chance alone, right? So outside the group, there's a variation that's due to chance as well. So we want to measure that, plus we're measuring the variance that is due to the independent variable in the groups. Don't worry if that's confusing. Come back to it, read it over. It will make sense, like, as you keep working with it and as you answer the question in the assignment, it'll make more sense. Okay, and so remember, in fact, you know what? I'm going to skip a lot of this because this is how to calculate it, and you don't actually need to know it for the assignment. There's a different way of calculating degrees of freedom, which we'll go over when we get to that part in the question. So yeah, I like this part. You don't have a 1 or 2 tail. The Anova test is they call it an omnibus test, but basically all that means is that it tests in all directions at once. So you wouldn't have that, 2 tail shape. It's going to imagine it more like this one, where you just have this kind of thing going on, okay? As we're working through the F stat and everything like that. I'll show you how to do this. You get your F stat, compare, and make the decision. Sorry. So this is how you calculate the Anova. So if we had to do it by hand, this is how we would do it. We would have to take the variance between the groups. This is just for a specific thing. And divide it by the variance within. Okay, so this variance between with the variance within. So once we have the variance between, in order to get them right, we need to get those, right? So we take the, I can't remember the word. This is not gonna, whatever it was, you remember we talked about variance and how it's squared. When we square it, it's the, remember we said in the descriptive stats, you get this number. It's the variance squared, and you don't need it for anything except this is what you need it for. And it's this right here. I'm so sorry that I can't remember the words. It's like something square, sum of squares, actually. It's sum of squares. Okay, so you're going to take the sum of the squares between and the degrees of freedom between, which I'll show you how to calculate later, and that gives you the variance between, and then you're going to take the sum of squares within and divide it by the degrees of freedom within, and that gives you the variance within. And so then, in fact, I realize now I should have started at the bottom of this. See, this is why I go over stuff before I talk. I do this for you guys. It's bottom up. So, yeah, you want to get the sum of squares between, the sum of squares within, and get the sum of squares total. Anyway, this whole thing is just how to calculate it. You probably don't need to know that. Determine the critical F. This will come out in the Excel table, just like on the T-stat. We're going to do set the alpha at 0.5 to 2.2. And again, this is just the warning that it only tells you the difference between the lowest and the highest group. So in our case, it's only telling us the difference between the full-time and the casual. That's the difference between that you're getting. And this is what it's telling you, if this is significant or not. You can run a post hoc test. This is beyond where, like way beyond this class, and might come up in a quiz question or something, but we can talk about it later. Don't worry about it for now. But the post hoc test would test for the differences between each group. Okay, this is again how to report it. We did this with the T-stat, so it's really, really similar.